All right, for this lesson, we are going to solve equations with variables on both sides. So we're just adding to what we learned last time. So let's start with example 1. We have 7 minus 8x equals 4x minus 17. So we're combining like terms. You guys have already done some stuff pretty close to this already if you haven't already done this. We need to move the x's on the same side and all the other numbers on the same side. So which number do we want to move? You want to start with the 7? So it's a positive 7, so we're going to subtract 7. So I'm left with negative 8x equals 4x. What is minus 17 minus 7? It's going to go further negative. Very good. All right, now what should we move?
4.
So we're going to subtract 4x. So negative 8 minus 4 goes further negative. Yep, negative 12x equals negative 24. And then our last step, correct, divide by negative 12. So I'm left with x equals a negative divided by a negative is a positive. 2 is your answer. Very good. Easy, right? All right, example 2. Nine x minus 5 equals 1/4. Open parentheses 16x plus 60. All right, so what's our first step going to be?
Distribute.
Yep, distribute the 1/4. So I'm just going to rewrite the beginning because we're not messing with that. What is 1/4 of 16?
4x.
Correct. And 1/4 of 60?
15.
Good. Now what would we like to move?
5.
Yep. I would move the 5. So then I have 9x equals 4x plus 20. And then we're going to move
4x.
the 4x. What's 9 minus 4?
5x.
And then in the last step,
Divide by 5.
divide by 5, which gives you
4.
x equals 4. Very good. Would you like me to do any more of those? Or do you guys feel good with distributive property?
Yeah.
Good?
Good.
So let's do a word problem. Sometimes word problems can throw you. So this is example 3. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars? All right, so now dive back into the paragraph and tell me the numbers that you read. We found out how many new cars we're selling? 78. And then how many old cars are we selling?
67.
So that's what we started off with. Okay, and then how much does new cars increase or decrease? What are they doing? And they're increasing. So we're going to say plus 6 cars each year. So X stands for each year. Now over here on the used cars, we found out how many are they increasing or decreasing?
Decreasing by 4.
So we're going to subtract 4 each year. And then the very last part of this equation, they want us to find out when the new cars are what of the old cars? Very last sentence.
The number.
Twice the number. So we actually have to double this.
Example 3.
Yeah, we're on example 3. So we actually have to double that little equation that we created. All right, does everybody understand how we came up with this equation? Because you are going to have to be able to do an equation.
Prompt.
Okay. All right, so what's our first step?
Distribute.
Yep, let's distribute this 2. 2 times 67 is?
1, 3, 4.
Yep. And then 2 times negative 4. Good. Now we combine like terms. So, yeah, let's move that. Good job. Minus 78. What's 134 minus 78? Yep. And then we should probably move the 8x. 6 plus 8 is? Yep. And then the last step? Yep. Very good. Oh, wait, this is a word problem, so what am I forgetting?
Your units.
Which is?
Cars.
Used cars sold.
Oh, yeah. Years.
Yep, it wants to know the number of years it takes for the other to double. So 4 years. Good. Any questions on how to make an equation? All right, turn the page. All right, the number of solutions. Equations do not always have one solution. You guys have seen that in some of your graphing, right? Where you had infinitely many solutions. An equation that is true for all values is called an identity. So the solution of an identity is all real numbers or infinitely many solutions. So sometimes you're going to come up on that. So let's do a couple of those so you recognize it. This is example 4. A. So we have 3x equals 3 times x plus 4. So, what's my first step? So we're going to distribute this 3. What's 3 times x? Just 3x. 3 times 4? 12. Now already you can look at this and go, oh my goodness, something's going to go wrong here. When I subtract the 3x, this is gone. Can 0 ever equal 12?
No.
So then you would just write no solution as your answer. And when you're working through these problems and you get to right here, where you see this 3x is going to cancel itself out, you can stop. I don't need you to keep going. You can stop right there and say no solution if you recognize it. If you keep going, that's fine. You get to here and you can say 0 cannot equal 12. Either way is fine, whichever is easier on your brain. Okay, so that's an example of no solution. Let's do another one. This is B for example 4. 2x plus 10 equals x plus 5. All right, so we need to distribute over here, right? So on the left, I get 2x plus 10. On the right, I have 2 times x. What's 2 times 5? What do you notice? Exact same equation on both sides. Now, you could solve this all the way down if you want. You're going to end up with 0 equals 0. This means there's all real numbers. No, this 0 does equal 0. So anything I plug in for x is going to work because one side's equal to the other side.
So that's your answer, all real?
All real numbers. Any number I plug in there. If I plug in a 0, it works. If I plug in a 5, if I plug in a negative 2, it's not going to matter. Understand? Do you want me to do any more of those? What's the other thing that this is called when they're exactly matching? It was your definition. Identity.
No.
You could also write that if you want to say that instead of all real numbers. It is a little shorter. Identity. All right. You want me to do another no solution or
No.
you guys okay? Cool. I mean, it's pretty easy stuff. So, all right, you need to do 3 through 13 odds, and 19 through 25 odds. And then IXL J6.